Hey guys, welcome to one more episode of Builder Nation. For today's interview, we have Nicolaus Radford, founder, president, and CEO at the company that is changing the way we think about autonomous robotic technologies. So welcome, Nick. Super happy to have you here today.
I love the show. Thank you. Well, I was super fortunate to spend the first part of my career around the space industry and got out of college and found my way down to NASA here in Houston, Texas, and was in the robotics world for a long time. We were developing this robotic astronaut we called Robonaut, and that was totally cool. Just such an amazing start to anyone's career. Just fascinating, just some of the best and brightest minds anyone could really hope to work around. And our mission was build a robot that can interact with some of the crew. And we're going to go to Mars one day, and we're going to need a whole lot of robot helpers when we do. And so we started looking at how robots and people could work together, especially on another planet, to build stuff, which caused us to really think about all the different kinds of autonomy and the electromechanical architectures that would be required to build a robot that had that kind of capability.
Okay, wow. So you were like super immersed in the NASA ecosystem. So why applying all of this knowledge to the ocean?
Well, operating in space is actually very similar to operating underwater. Extremely harsh environments both ways. And when you're trying to build a robot that goes to a faraway location to interact in a useful way with the environment to do useful work, you have to develop certain advancements in not only artificial intelligence, but certain autonomy architectures and also the morphological form of the robot. And while I was working at the lab in NASA, we would get visitors, and those visitors would say, have you ever thought about all the stuff in the ocean and how directly applicable what you guys are working on here would be? And at the time, I had never really thought about it. Like many of your listeners and maybe yourself, the ocean economy is not something you really think about every day, even though it touches probably every aspect of your life. In fact, the way that you and I are communicating, 99% of the world's data that is transferred around the world flows in ocean telecommunications cables, 99%. And a lot of the food that you eat comes from the ocean economy. And a lot of the energy that you use comes from the ocean. A lot of goods are transported through the ocean. And so there's this multi-trillion-dollar economy that has all sorts of infrastructure. And that infrastructure needs inspected and maintained and repaired. And even today, it's very important around infrastructure security. So I started looking into it, got really inspired. I think it's sort of turned into an obsession at this point. And my thought was, how can I take everything that we had been developing at NASA around autonomous robotics and how to send them to other planets? And how would some of that apply to solving these very pressing problems in the ocean economy? And so myself and what turned out to be about 25 other NASA scientists and engineers over probably the first 2 years of our company's life left NASA and decided to apply that skill towards changing the blue economy for the better.
I know that you guys are actually working with the government, right? Working with Diverse Marine to build two robotic navies. So how is that like?
The best expression of what we're trying to do is take an autonomous surface vessel that can sail really far, a few hundred miles from the shoreline, and have it drop in the ocean an autonomous robot. And the pair of them work together to do a lot of the tasks that are required around inspection, maintenance, and repair. And what we're trying to do is really reduce the reliance on the alternative method, which is a really gigantic ship that might have 60 people on board. It costs a ton of money every day to operate one of these things. And it puts out about 70 metric tons of CO2 per day. And so if you look at the amount of market that Nauticus can cover off, you're talking saving millions of cars of effective emissions each year. And that's just one small segment of how the ocean operates. A lot of our technologies could extend to autonomous shipping, which accounts for about 3% of global emissions. And so I think robotics in general, and especially intelligent machines, are going to be able to infuse themselves in the ocean economy and really look at how do we conserve this environment better. Nauticus has the mission to be the most impactful ocean robotics company. And I think that impact is going to be measured in a lot of different ways. One of it could be economic. The other could be the social impact on carbon emissions and how we reduce that. The ocean is the largest sink of carbon dioxide, about 31% of the carbon dioxide is actually absorbed in the ocean. And so looking after this, it's a big deal. Part of our mission is to bring more awareness to this very precious economy and how it hasn't been updated in quite some time. And a lot of our new energy is going to come from there with offshore renewables. That's going to require advanced robotics to service properly. And the energy transition is going to require a lot of minerals and rare earth materials, of which more are found on the bottom of the seabed than all 7 continents combined. So it's going to be an essential element to the changing economy, especially through our energy transition.
Great perspective. I think it's really interesting, everything that we're finding out about the ocean. Recently, we spoke with Anthony Delmare from Bedrock. They're doing ocean exploration as well. And I think it's great and fascinating what you guys are doing there. So you were mentioning the economy and the transition. So I would like to ask you, I know that you guys are starting working with the government and now you are joining the commercial sector. So what was the main challenge there?
Well, there's a lot of need in the government world around infrastructure security, and a lot of the technologies that I've been speaking about, how to operate robots in a remote way where you don't need a lot of people deployed offshore to run them. A lot of those principles apply whether you're working in security interests or whether you're working commercially. So we were fortunate enough to have a lot of government support early on and develop this very rich and broad IP portfolio that we're now commercializing out in this robotic fleet that we're building. But the commercial challenge is, it's kind of the commercial industry writ large. It's very slow. The offshore industry is very slow to adopt new technology. The cost to develop and deploy commercially in the ocean space is very high. And so typically there's a large inertia associated with that. So if you have a solution already, you're very resistant to change. Except change is in Nauticus's blood and we like busting up the status quo and doing things differently. I think we should really look and take a 21st century view of how business should be conducted in the ocean economy.
I was looking through an article and I know that it's really expensive to do work underwater.
Yeah, it can cost between upwards of $100,000, $150,000 a day to charter and procure the services. And what we're trying to do is cut that by 75%. And not only we're cutting that cost by 75%, but we're removing about 95% of the emissions of doing the equivalent work.
I know that you guys have this robot called Aquanaut, but I'm curious to ask, why do they call them the happiest robot on the ocean?
We had this model of the robot and somebody drew a smiley face on it, and it just looked like the happiest robot in the ocean. If you look at the equipment that has been used typically to explore and do the services in the ocean world, it looks more like heavy construction equipment, something that Caterpillar might have made. I feel that that doesn't look like the kind of technology I think represents what the future of conducting business looks like. And I think one of the greatest compliments we ever received on LinkedIn is we posted a picture of Aquanaut for the first time. And this comment on the thread said, wow, that looks like it just fell out of Pixar. And, you know, to me, that was exactly right. We wanted to not only inspire a new way of doing something, but a new way it could look while it was doing something. And our form definitely follows function, and it's very purposeful in the way that it was designed. I have this feeling that if it's worth doing cool, and we take pride in the way things look.
It does look great, I have to tell you. And the videos are amazing, and I cannot believe we have reached that point in technology. So congratulations. So talking about challenges in the hardware industry, what would you say has been the biggest one and how did you solve it?
The challenges of a hardware company center primarily on the fact that we're developing hardware. From an investment standpoint, it typically doesn't get a lot of respect. There's a real high tolerance of funding software companies in the investor community, and as a consequence, a very low tolerance for funding hardware companies. If you look at the amount of capital that's typically deployed, in any given year, the US is putting out $150 billion, $175 billion of venture capital funding into the startup world. 60% of that goes to software-only companies, so a bunch. 32% of that goes to healthcare, fintech, consumer-facing goods. 8% of that goes to industrial technologies. And we live in a really physical world, right? If we're going to do some shit, we're going to have to build some shit. Pardon the expression. I just think there's an underappreciation of the kind of business that a hardware-oriented company can really afford you. It's typically expensive. So if you get it right, you have this natural moat around you that keeps people competing with you. Companies, some of them provide some of the highest returns. I think the last 30, 40, 50 years has really been around the ubiquitous manipulation of the virtual world. And I think the next 30, 40, 50 years is going to be around the ubiquitous manipulation of the physical world. And that's going to take companies like mine and the incredible engineers and scientists that staff our company. The talent here is just second to none. But it's going to take their inventions and their new way of thinking to really alter how we decide to conduct business in the future.
I've been with different CEOs and founders in the industry. Most of them, if not all of them, say that building hardware is hard. A lot of companies have survived the pandemic, and the supply chain issues were a real thing. So how did you manage that?
Funny enough, we're not wearing masks anymore, but the supply chain very much still acts like they are. And it's hard to get parts. They're slow to come around. Some of the criticisms of a hardware company is you just can't recompile your code and have a new version. And so it is difficult sometimes iterating and testing. There is an expense there, but also there's beauty in it. I used to code, a little out of practice now, but I've slung some code in the past. And yes, there's an incredible feeling that you get when your program compiles and it spits out the data that you want, but it doesn't even begin to compare to what it's like to actually create something of a physical form, like a robot, which is a beautiful interdisciplinary art where you're combining mechanical engineering and electronics and software engineering all blended together to have this creation function. And it's just such an intoxicating feeling.
You know what, Nick? I see passion. Whenever you talk about the ocean, about the company, we can see it. So thank you so much for sharing that with our audience as well. I wanted to ask one of the last questions. What would you say are the next steps for Nauticus?
We have the beginnings of our commercial fleet that's being produced right now. We're manufacturing part of it in Vancouver, part of it in the Isle of Wight in the UK with Diverse Marine you mentioned earlier. And so the next phase of the company is really to get that out into the world. We've been very aligned with the government world. We've gone through our pre-production prototypes, all of our conceptualized demonstrators. Some have been in revenue generating capacities, but this next march for us is getting that fleet finally out into the world and in the hands of the users. And so we're really pumped up about that. And that's an intermediate phase. We have greater ambition than that, but every major change starts with a small step. And so we need to get through this first step.
We can wait until this new release comes up. So thank you so much, Nick, for being here, for sharing your experiences. Do you have any advice for future entrepreneurs or CEOs starting on the ocean path exploration?
I think maybe just in general for entrepreneurs, you got to have tenacity, right? With enough time, you will figure it out. It's easy to give up. It's easy to get depressed. It's easy to feel like the whole world can be against you at times. But finding a good mentor, finding a good team, when you get that part right, you feel like you can do anything. And so persistence definitely pays, as they say. Just be prepared for the blood, sweat, and tears.
Do you have any social media handles? Where can people find you or the company?
I'm on Twitter at @nradford in profile. It's not hard to find me if you just search my last name.
And remember, guys, that you can also find more information, interesting articles, interesting interviews, just like this one with Nick, directly on our website, ControlHub.com/builder-nation. We would love to hear from you. And once again, Nick, thank you so much for taking the time. We highly appreciate it.
Lisa, that was awesome. Thank you so much.